Hello all, this is Mr. G, and after this video we should be able to find missing sides in right triangles. So this objective actually should sound pretty familiar. You already know how to find missing sides in a right triangle. Whenever you see a right triangle, you should think, oh, I might be able to use the Pythagorean theorem. A squared plus b squared equals c squared. So keep that in mind as we're approaching this lesson. But before we get too far into this lesson, we have to take a quick second and make sure, wait a minute, do we remember everything we need to remember to start this lesson? In our last video, we talked about sine, cosine, and tangent, these trigonometric ratios, and using SohCahToa to help us remember the formulas, the order that we pick the sides to compare in each of these three ratios. Remember, that's all sine, cosine, and tangent are. They're just three ratios, three special comparisons of sides in right triangles. So pause the video right here, answer these questions, make sure you remember how to do this. We'll go over the answers in 3, 2, 1, let's go. So sine of A is our angle, so that's our reference, that's where we're sitting and looking at the triangle from. And we're talking about sine, so S stands for sine, so we want that first section of SohCahToa, S-O-H, which means sine is opposite to hypotenuse. Opposite to hypotenuse. Now, opposite A is 16, and the hypotenuse is 34. So 16 over 34. We can simplify that, divide them both by 2, and get 8 over 17. So there we go. That's our first answer. They asked us for a ratio. We gave them a ratio, so we're done. Let's take a look at the next one. Tangent of B. So we're looking at angle B now, using that as our reference. And it's tangent, so we got to focus on TOA, the last part of SohCahToa. Let's see. So T is tangent, O is opposite, A is adjacent. So tangent is opposite to adjacent. Opposite angle B would be 30. That's across from our highlighted angle. And the adjacent leg would be 16. So we get 30 over 16. But we can simplify that, divide them both by 2, and we get 15 over 8. That's our answer there, 15 over 8. Just 2 more to go. I'll tell you what, let's scroll down so we can see this more easily on the video, or on the screen, I should say. Cosine of A, dealing with A degrees. I forgot to bring down SohCahToa. Let's grab that and this so we know which part we're looking at. And let's put it down here, why not? And cosine is C, so we're looking at the middle part of SohCahToa. So cosine is A for adjacent, H for hypotenuse. That's the ratio, that's the order we're going to compare these two sides. The leg that's adjacent to A would be 30. Now, I guess I can see some students being confused, thinking, wait a minute, isn't that on a diagonal? Shouldn't that be the hypotenuse? But remember, to find the hypotenuse, which is actually 34, to find the hypotenuse, you always treat the right angle like it's an arrow. It's pointing at the hypotenuse. And then we can simplify, divide them both by 2, and get 15 over 17, and we're done with that. Last one to go. Sine of B, which means we're focused on B as our angle, our home base, where we're looking at the triangle from, and it's sine, so we want the first part of SohCahToa. That's what the S stands for. Sine, O is opposite, H is hypotenuse. And let's go through this. I'm going to need some more room, so let's slide this away. Yeah, that's what I wanted. That's better. So B opposite would be 30, and the hypotenuse is 34. So we get 30 over 34, and that's 15 over 17. And oh, actually, we could have gotten this a lot quicker if we had remembered that trick we learned in the last video, that the cosine of one of the acute angles will always be exactly the same thing as sine of the other acute angle. So essentially, if we remember that cosine of A is the same as sine of B, that could have saved us a lot of time. Hopefully you remember that from the last video lesson we watched. All right, so now that we remember all that stuff, we pulled SohCahToa and sine, cosine, and tangent back to the front of our brains. Let's take a look at example 1. Example 1 says, given that sine of x degrees equals 1 over 3, find the missing side lengths of the triangle. So in this triangle, we have one side length, 18, and we have to find the other two sides. And we notice this is a right triangle, which immediately makes me think, oh, the Pythagorean theorem, a squared plus b squared equals c squared, is an option. That's one way we can sort of find missing sides in a right triangle. Not any triangle, but a right triangle. So maybe we can try and do that. We know 18 is C, that's the hypotenuse, so we can plug that in here. And then we sort of run into a wall because we don't know either of the other sides. So it would just be like a squared plus b squared, and there's too many variables here. We can't solve this. So the Pythagorean theorem is actually not going to help us, well, at least not yet. But they give us another piece of information. They tell us that sine of x degrees equals 1 over 3. Well, okay, so sine, let's use SohCahToa and see what we can do with this. So sine of x degrees, I'm just going to copy that so I have some more space to show my work. That's 1 over 3. But we know sine, if we use SohCahToa, remember S stands for sine, so we focus on the first part of SohCahToa. Sine is opposite over hypotenuse. So essentially, they're saying that the opposite over hypotenuse would equal 1 over 3. But in our actual diagram, if we're focused on x degrees, okay, well, we don't know what the opposite side is, so we just put a question mark there. We've got nothing there. But we know the hypotenuse. The hypotenuse is 18. And what we have here is just a proportion. We can solve this. We can cross multiply. In fact, we don't actually even need to cross multiply. We notice that to get from 3 to 18, we just multiply by 6. So we can do that same thing with 1 times 6, and then we get 6 for our unknown side. So this opposite leg is 6 units long, feet, inches, whatever it is. It doesn't tell us. And now that we have two sides, now we can use a squared plus b squared equals c squared. Because we know 18 goes in for c. A could be 6, it doesn't matter. And b, we don't know, so we'll just leave it as b squared. And then we just solve. We know how to solve these equations. So we get 36 plus b squared equals 18 squared. I could not do that in my head. 18 squared. And we get 324. 324. Then we just take away 36, do our algebra, and we end up with b squared equals whatever that is. I don't feel like making a mistake in my head. And we get 288. Then we take the square root of both sides to get rid of that power of 2. And we get b is, this is going to be an approximation, second square root of 288. And we get 16.97. 16.97. So that is the last missing side. So hopefully you see that knowing what this ratio of sine was sort of helped us unlock this triangle. We only had one side, but since we knew a ratio, we could sort of, okay, set up a proportion, use that special equation, and get to another side, which then let us use the Pythagorean theorem. A squared plus b squared equals c squared. So let's take a look at example 2. It says, find the missing side lengths of the triangle. So almost the same exact problem. We still have a right triangle. We're given the hypotenuse, and we have to find the other two sides. Okay, so this shouldn't be too bad, except there's something pretty drastic missing. In example 1, they gave us that sine of x degrees equals 1 over 3. Here, they don't tell us that. Well, I mean, we've got 35 degrees. We've got an angle. So instead of like sine of x, like we had here, like if we had sine of 35, if they would give us that information, then all of a sudden we'd be able to do this problem. But right now, we're completely stuck. So it's almost as if it'd be nice if there was some way we could look up or know what sine of 35 degrees is. And that's where our graphing calculator is going to come in. Because a graphing calculator, or not just a graphing, but any scientific calculator, or most calculators you have on your phones or a laptop or something like that, they can look up sine, cosine, and tangent for you. You just have to know how to ask it. Now, on my particular TI-84 app that I have, the first thing I have to do is I have to go to mode to make sure I'm in the correct mode. So mode is right there. Hopefully you saw that. It's right next to the second button at the top. And one of these settings is actually set incorrectly for what we want, because we're in degrees here. This is 35 degrees. But if you look at my calculator screen, hopefully you see that degree is not highlighted. I'm going to go down to it and go over. Degree is not highlighted. Radian is highlighted. Now, radians and degrees are two different ways of measuring angles. It's sort of like the difference between feet and meters, or centimeters and inches, or miles and kilometers, or Fahrenheit and Celsius. They're just two different units of measure for the same thing. In this case, it's angles. But we don't want to be using radians. We want to tell the calculator, oh, we're using degrees. When I give you that 35 for the angle, I'm in 35 degrees. So make sure you're in degree mode, whether you're in an 84 calculator or a calculator on your phone or a scientific calculator. Make sure you're in degree mode. Now I'm just going to hit second quit to get out of this. And now I can type in sine 35 and it gives us the decimal. It gives, I mean, it's not as nice as just 1 over 3, but essentially it tells us what it is. So now that we know sine of 35 degrees is, what is this, 0.5735, or I guess around to 36, we can use that to find this missing side because sine is opposite over hypotenuse. So here's the thought process. All right, we know sine of 35 degrees, that's opposite over hypotenuse, which is the same thing as, in this case, opposite would be the unknown side, so I'll put a question mark there, over 15 is the hypotenuse. That's why it's so critical that we know how to use SohCahToa. That's why we took that time to pull that prior knowledge back up to the front of our brains, because we need to be really good at that for this lesson. And then based on the calculator, okay, we know the sine of 35, that's 0.5735, or 36, excuse me. That's going to equal something over 15. Well, we know how to get rid of division. To undo division, we multiply both sides by whatever the denominator is. So the 15s will cancel out. And then we end up with the opposite side. That missing side right there that we're looking for is just going to be 15 times 0.5736. And we'll get approximately 8.60. 8.60. So that's one missing side. And then to find this missing side, obviously we would just use the Pythagorean theorem. I'm not going to waste your time and go through all that because the key part of this lesson was noticing, excuse me, the key part of this slide, this example, was noticing that, or knowing rather, learning that we can look up whatever sine, cosine, or tangent is for any angle using a graphing calculator or any type of scientific calculator, I should say. All right, so let's take a look at our next example, example 3. So here we've got to find x, and we're given 40 degrees and 7 inches. We notice it's a right triangle, and from now on, anytime you see a right triangle, I want you to think of two things: the Pythagorean theorem and trig, SohCahToa. Now, you won't always need one of those things, but essentially when you see a right triangle, that's a clue that you might need one of those tools, Pythagorean theorem or SohCahToa. In this case, the Pythagorean theorem would not be useful because we would need an additional side. We've got one missing side, which is okay for the Pythagorean theorem, but we only have one side that's a number. Since this side is missing, Pythagorean theorem is no good, so let's use SohCahToa. And actually, there's another clue here that tells us SohCahToa is probably going to be useful. We've got an angle, a numbered acute angle. That is probably going to tell us, okay, that's a clue rather, that, all right, SohCahToa is probably going to be a good choice. So we're using 40 degrees. The first big choice we have to make is, okay, which one do we want? Is sine going to be helpful? Is cosine going to be helpful? Is tangent going to be helpful? Because just because we use sine on the last two examples doesn't mean we're going to use sine every single time. Like, so actually, let's say we make that mistake. Let's say we think it's going to be sine every time. Let's see what happens. All right, so it's going to be sine of 40 degrees. Well, that's opposite over hypotenuse. And then if we look at this, the opposite, oh, that's this side. That's the blank side. So we've got the blank side over the hypotenuse, which is 7. I mean, okay, so that can help us find the blank side, but we don't want to find the blank side. We want to find x. So let's see if there's a faster way we can get to x without using that blank side. So here's the way I think of this. If you're ever having trouble picking sine, cosine, or tangent, first pick your angle. Then it's a matter of figuring out, okay, what sides do I have information for, and what sides do I not have any information for? So I always look for the hypotenuse first. The hypotenuse, the 90 degrees points to it, so we see 7 is the hypotenuse. Then opposite is the leg that doesn't touch the 40 degrees. So across from 40 degrees, we have the opposite side. And then x, the last one, has to be the adjacent side because it's the only one left. Just by process of elimination, we found the hypotenuse, we found the opposite. The last one must be the adjacent. Now, we only need 2 of these in a sine, cosine, or tangent because sine only has 2, cosine has 2, tangent has 2. So one of these, opposite, adjacent, or hypotenuse, we actually do not need. We can just sort of ignore. And the one we want to ignore here is opposite. Opposite's not going to be helpful here because it's a blank side. There's no number there. There's no variable there. So we're just going to ignore it. It's not that we can't find it or can't use it. It's just not going to be that helpful. So essentially, we're looking for an A for adjacent, and an H for hypotenuse. So we sort of check, okay, is it sine, cosine, or tangent? Which one has A and H? And hopefully you're seeing it's cosine. It's that middle part of SohCahToa, C-A-H. That tells us we're going to be using cosine. Now, it's cosine of the angle, because if you remember, it's always sine, cosine, or tangent of the angle, and the angle we chose was 40 degrees. Oh, some students ask, would we ever choose 90? Not in geometry. So don't worry about choosing 90 degrees. We're only going to use acute angles, at least at this point. When you get to Algebra 2, pre-calc, things will be different. But right now, we're only going to focus on acute angles for sine, cosine, and tangent, or at least non-right angles. Okay, what was next? So cosine of 40. Oh, well, we know that's adjacent to hypotenuse, and adjacent is x over the hypotenuse is 7. Now, I'm not going to plug this into the calculator and get a decimal just yet, because I don't want to, like here in number 2, we essentially rounded twice. We rounded there to get our decimal, and then we rounded there to get our answer for the missing side. I only want to round once from now on. I want to round at the very end. So I'm not going to type cosine of 40 into the calculator yet. What we are going to do is say, okay, how do we get x by itself? What's with x that needs to go? And it's the division. We have to undo this division. And we remember from algebra, to undo division, we multiply by the denominator, whatever the denominator is. So here it's a denominator of 7, so we multiply both sides by 7. That's the only way you can cancel out division, is by multiplying by the denominator. And then we get x on this side, and on the left side, we can just type this right into our calculator. So I'm going to hit, we can clear that up. It's going to be 7 times cosine of 40, and we can close the parentheses, and then we get our answer. So 5.36 we'll round to. 5.36 is x, and we are finished. Now, if you're ever kind of lazy with your calculator, you actually don't need to hit all those buttons. You can just hit 7 cosine 40 and not even close the parentheses, and then it will tell you, oh, okay, sure, or not tell you, but it'll know that you mean 7 times. Whenever a number and sine, cosine, or tangent are right next to each other, or rather when the number's in front of sine, cosine, or tangent, it means multiplication. Now, even though I didn't close the parentheses there, it doesn't matter for these problems, but it will make a difference if you do it in the opposite order. Like if I hit cosine 40 and then times 7, then you want to close your parentheses. Because notice what happens if I don't. If I just hit cosine 40 times 7, then we're going to get a completely different answer. Right? That's not the correct answer, because what the calculator is doing that time is first it multiplies 40 times 7, gets a new angle, and then finds the cosine of that angle. So you can get away with not closing the parentheses, but just be careful with that. Just be careful. All right, that's enough of that. Let's move on to example 4, and this one I want you to try on your own. So pause the video right here, give this problem a shot, come back when you think you have an answer. We're going over 3, 2, 1, let's go. It's a right triangle, so we're going to use SohCahToa. Since we only have one side given to us, 12. To pick sine, cosine, or tangent, we need to pick our angle first. That's always the most important choice. What angle do we use? Here they only give us 70 degrees besides the right angle, so let's use the 70 degrees. And let's label. So the hypotenuse is here, that's across from the right angle. And opposite would be x, because it's across from 70 degrees. And 12, the last one remaining, has to be the adjacent. And the one that we don't need is the hypotenuse, because it's blank. So then we look at SohCahToa. Which one has an A for adjacent and an O for opposite? O and A would be this one. Toa, meaning tangent. So we're going to use tangent of the angle 70 degrees equals, and the ratio is O to A, that's opposite, x, over adjacent, 12. And this is always the way we're going to set these trigonometric equations up. It's always going to be sine, cosine, or tangent of the angle equals the ratio. It's always going to be in that order. And now we've just got an equation to solve. I mean, this is a single step equation. Just because there's like a weird tangent here, a weird trigonometric ratio, don't let that throw you off your game. You know how to do this. X divided by 12, cancel out that division, multiply both sides by the denominator. Here the denominator is 12. So we multiply by 12 to cancel that out, and we can type this right into the calculator. 12 times tangent of 70, and I'll close my parentheses this time just to try and be a good example, and we get 32.97. 32.97 is our answer for example, what are we on? Example 4. Hopefully you got that one on your own. Let's take a look at another one. Now, example 5, at first glance, it might look, okay, this is just the same one. I'm just going to skip ahead to the next example, but you might not want to do that because every time I teach this lesson, students, not all students, but some students get thrown off by this. So I want to talk about this. We've got to find the value of x. X is a missing side in a right triangle, and we only have one known side, so we're probably going to use SohCahToa. Now, at this point, this is where some students get confused because now it's time to pick our angle, and some students freak out because they're like, well, wait a minute, I've got a 65 and a 25. Which one do I pick? Is one right? Is one wrong? No, it doesn't matter. Just pick one. It does not make a difference. You can use 25, you can use 65, and you will get the same exact answer. I'm going to pick 25 just because that's the one I saw first, but I'm actually going to show you how you get the same answer doing it both ways. So if we use 25 degrees, then let's label. This is the hypotenuse, 15. Opposite is across, and adjacent is right here. Again, the last one has to be adjacent, and we know it's adjacent because it's right next to our angle of 25 degrees. Okay, we don't need opposite here because it's blank, so that means we want adjacent and hypotenuse, so that would be cosine. So this would be cosine of 25 degrees equals the ratio. It's adjacent to hypotenuse. Adjacent is x over the hypotenuse is 15. Now we just cancel out the division. We multiply both sides by 15, and let's see what that gives us. 15 times cosine of 25, and we get 13.59. So we get 13.59 equals x, because the 15s cancel out. So that's one way. But what if you out there had chosen 65? Would you have gotten the same answer that I just did? Let's check it. Well, if we're looking at 65 now, things are slightly different. This is still the hypotenuse, but the opposite side is now x. X is opposite, and then this blank side is adjacent. But we still don't need the adjacent side, or rather, we still don't need the blank side, so we can cross off the green adjacent. And now we're looking for opposite and hypotenuse. So O and H, that would be sine. So if we use 65 degrees, that would be sine of 65 degrees equals O over H. So O is x for opposite, H is 15 for the hypotenuse. Then we just multiply by 15 on both sides. Just like we did earlier. Multiply by the denominator, cancel them out, and we get 15 sine 65. Oops, missed the sign. Let's go back. Sine of 65, close parentheses, hit enter, and we get the same thing, 13.59. So, oh, don't do that. There we go, that's what we wanted. So we get the same thing whether we use 65 degrees or 25 degrees, but what changed is whether we wanted sine or cosine. And again, that should not surprise us, because hopefully we remember from, I forget if it was this video lesson, we definitely talked about it in the last video lesson, sine of one angle is the same thing as cosine of the other angle. So if we pick one acute angle, we want sine. If we pick the other acute angle, then we would use cosine. Anything more to say about that? I don't think so. Let's take a look at example 6. Now, again, just like the last one, it might be tempting to think, okay, I can't believe that this video is still going. These are all just the same types of problems, but there's something different here. All right, don't just skip ahead to the end. Stay with me. We got to find the value of x, and we're looking for, again, it's a right angle with only one side length given, so that means SohCahToa. Pythagorean theorem is not going to be helpful here. We pick our angle, which is 35 degrees, and let's see, the opposite side is here, the hypotenuse is there, x, and this is adjacent. We don't need the adjacent because it's blank. So opposite and hypotenuse, well, oh, that's just sine again. I'm seeing a lot of sine, it seems like. So it's sine of the angle 35 degrees equals O over H, which is 20 over x. Now, at this point, I would not blame you, or rather, up to this point, I would not blame you if you were sitting there thinking I'm a liar, thinking, Mr. G, this is the same thing we did last time. We wrote down SohCahToa, we labeled our sides after we picked the angle, then we wrote our equation. This is the same thing, but there's something different here. What's different is in our ratio. So far, every single one we've seen, the numerator has been the variable, but now the denominator is the variable. The variable x that we're looking for is in the denominator, which is going to change not the geometry, not the trig, but it's going to change how we solve this. It's going to change our algebra slightly. We still have to get rid of the division, so we are still multiplying both sides, but we're multiplying both sides by the denominator, remember. So we're not going to multiply by 20. Don't do that. 20 is not the denominator. In the denominator, we see an x. So we have to multiply both sides by x. That's the only way to cancel out the division. So make sure you remember that. To cancel out division in an equation, you multiply by the denominator, whatever the denominator is, whether it's a number, whether it's a variable, whether it's some crazy expression you've never seen before. Multiply by the denominator. So let's see what happens here. We get 20, and this is where some students get caught off guard. They see this, and normally this is the point where we just type things in our calculator, and we can't do that, not just yet. And especially if you have a graphing calculator, some students fall into a trap. If you look right below the mode button, you'll see x, t, theta, and n. And when you hit that button, an x shows up. And some students think, oh, this calculator is awesome. I can just type in x times sine 35 and it'll give me the answer. No, it won't. It'll give you an answer, but it's not going to be right. Because, like, look what this calculator thinks x is. If I hit enter just with x, this calculator thinks x is 0. So if I hit x times sine of 35 and then hit enter, it's just got, 0 times that? It just spits out a 0. So for some reason, this calculator always thinks x is 0. So you don't want to use the x button unless you're graphing, unless you're telling the graphing calculator that's a variable. But that's a lesson for another time. So here, all we can do is just, all right, x times sine 35. And actually, it should not surprise us that we're not done yet, that we can't get an answer because x is not yet by itself. Remember, that's always the goal in solving an equation. We want to get x by itself. And what's still with x? We see multiplication. But we know how to cancel out multiplication. We use inverse operations. We're going to divide both sides by something. But the question is, what are we going to divide by? What are we multiplying by x? Well, we're multiplying sine 35. So that's what we need to divide by. And again, some students get freaked out by that. But remember, sine 35 is just a number. I can hit sine 35 and get a decimal. So don't let that freak you out. We're just going to divide both sides by that weird decimal, whatever sine 35 degrees is. This cancels that out. The division cancels out the multiplication. And we're left with x equals, now we can type this in our calculator. 20 divided by sine of 35. And we get 34.87. 34.87 it rounds to. And we're done. So the only difference there was that the x was in the denominator. Everything else was the same, but that changed our algebra slightly. But setting up the equation, we followed the exact same steps. Final example for this lesson. I want you to pause the video, try this one on your own, come back when you think you have an answer. 3, 2, 1, let's do it together. So we got to find the value of x, and we're going to use SohCahToa, obviously, because there's one side length given, but that's not enough for the Pythagorean theorem. So SohCahToa. The angle they give us is 20 degrees, or rather the acute angle they give us, because we're never going to use 90 degrees for sine, cosine, or tangent, not in this class at least. And 20 degrees is going to be, now we got to label my sides. What am I doing? So the hypotenuse is right there across from 90 degrees. Across from our highlighted angle, our reference angle is 15, so we can put opposite there. Opposite means across. And then the last one, the only other option we have is adjacent. But again, that makes sense because x is right there touching our angle of 20 degrees. It's touching that vertex. All right, which one do we not need? We don't need the hypotenuse because it's blank. So opposite and adjacent, O and A, that's going to be TOA. So we need tangent. So I'm going to scroll down slightly. We use tangent of the angle, 20 degrees, equals the ratio. Tangent is opposite over adjacent. Opposite is 15, and the adjacent is x. Our equation's done. Now we just have to solve it. And, okay, x is here with the division, so we have to get rid of that division, so that tells us we're multiplying both sides by the denominator, whatever that is. And in this case, it's x. So we multiply both sides by x. Now we got that back. And that gives us 15 on the right. On the left side, we can't do anything with that yet. We can't type that into a calculator, so it's just x times tangent of 20 degrees. And since x is not yet by itself, there's still more to do. We have to undo that multiplication with division. And we divide by whatever we're multiplying by. We're multiplying x by tangent of 20, so we divide both sides by tangent of 20 degrees to cancel out the multiplication. Then we get x equals whatever that is. I can't do that in my head, obviously. 15 divided by tangent of 20. 20, please. 15 divided by tangent of 20, and we get 41.21. And we are finished. Hopefully this lesson made sense. As always, if you have questions, you can put them in the comments below or get in touch with me. Enjoy the rest of your day.